Now let us see energy level diagrams for molecules starting from atomic number 1 to atomic number 10. So as you go on seeing this, you will be able to write it on your own. Now atomic number of hydrogen is 1. There are 2 hydrogen atoms in hydrogen molecule, which will thus have 2 electrons. So hydrogen molecule, how many electrons it will have? 2. Why? Because one hydrogen atom has 1 electron. So 2 hydrogen atoms should have 2 electrons. So we need to write electronic configuration for hydrogen molecule now. You are familiar with writing electronic configuration for atoms, right? So we will see. Now hydrogen molecule is formed by combining of 2 hydrogen atoms. These are atomic orbitals of 2 different hydrogen atoms having how many electrons each? 1 electron each. I have written 1 electron and I have written another electron for hydrogen atom. Correct? 2 atomic orbitals combine to form 2 molecular orbitals. That is what we had studied. One is called BMO, bonding molecular orbital, and the other one is called as anti-bonding molecular orbital. Since the first bond formed a sigma bond, I have written sigma and sigma star for anti-bonding. So what happens? Electrons are placed in the orbitals, molecular orbitals, based on Hund's rule. So where will the electron go? It will go to that molecular orbital having less number of less energy. So BMO is having less energy. Therefore, this electron will come to BMO first. And then this electron will come here. So you have 2 electrons in bonding molecular orbital and no electrons in anti-bonding molecular orbital. Okay. So how do you write its electronic configuration? Which orbital is this? This is 1s for one hydrogen atom. This is 1s for another hydrogen atom. They have mixed together to form bonding molecular orbitals, which are of 2 types, bonding molecular orbital and anti-bonding molecular orbital. So how to write the electronic configuration? From where has the electron come? From 1s. So write 1s. Which bond is formed? Sigma bond is formed. Correct? Sigma bond. Bonding or anti-bonding? It is bonding. How many electrons are here? So it is 1s to sigma. Okay, 1s to sigma and sigma star 1s0. Since there aren't any electrons, I am not showing here. So 1s to sigma is electronic configuration of hydrogen molecule. So let us look into bond order. If you are not following this, for further molecules you will be able to understand. So what is bond order? Bond order is equal to half of the number of electrons present in bonding molecular orbitals minus the number of electrons present in anti-bonding molecular orbital. So half I have written here. Number of electrons in bonding molecular orbital, how many are there? 2. How many are there in anti-bonding molecular orbital? It is 0. Therefore 2 minus 0 is equal to 2 minus 0 is equal to 2. Half into 2 is equal to 1. So bond order is 1. What does bond order tell us? It tells us about the number of bonds present between the hydrogen atom. Therefore, there is 1 bond between the 2 hydrogen atoms in hydrogen molecules. Since the molecule has no unpaired electrons, are there any unpaired electrons here? No. So no unpaired electron. Therefore, hydrogen molecule is diamagnetic in nature. If there are unpaired electrons, then it should be, yes, very good, paramagnetic. So what does bond order tell us? It tells us the number of bonds present between 2 atoms. What is bond order of hydrogen molecule? 1. What does it mean? There is only 1 bond between 2 hydrogen atoms in hydrogen molecule. Now we will go to the next molecule and check whether it exists or not. So which is the element having atomic number 2? It is helium. So we will check whether the molecule exists or not. Now we will check whether helium molecule, does it exist? Atomic number of helium is 2. Therefore helium molecule contains how many electrons? One helium has 2 atoms, 2 electrons. Helium molecule contains how many atoms of helium? 2. So one helium contains 2 electrons, therefore helium molecule He2 should contain 4 electrons. Now we will write electron level diagram, energy level diagram for helium molecule. So for one helium, how many electrons are there? There are 2 electrons. For another helium, there are 2 electrons. Okay. Now they are going to sit in your PMO and ABMO. So this is sigma, this is sigma star. So one electron from here comes and another electron from other helium. They get paired. So 2 more electrons are left out. So there is no other place. Therefore they will go to anti-bonding molecular orbital. So bonding molecular orbital has 2 electrons and anti-bonding molecular orbital has 2 electrons. So the bond order will be, for helium molecule will be half of Nb minus Na. Number of electrons in bonding molecular orbital is 2, anti-bonding is 2, so 2 minus 2 is 0, 0 into half is 0. Therefore, no bonds are present between helium atoms. Hence, helium molecule does not exist. It means helium is monoatomic. Now check. He2 plus. So does helium molecule having 1 electron less, does it exist? Plus 1. Here plus 1 means what's deficiency of 1 electron. Therefore He2 plus should have how many electrons? He2 has 4. So He2 plus has 3 electrons. So 2 will go to BMO, another 1 will go to ABMO. So bond order is equal to half minus bonding molecular orbital. How many electrons will be there? 2. In antibonding there will be only 1 electron because it is He2 plus. So since bonding molecular orbital, bond order is equal to half. 2 minus 1 is equal to 1. 1 into half is equal to half. Since bond order is positive, He2 plus molecule exists. Because it has how many unpaired electron? In antibonding there was 1 electron. So because it has 1 unpaired electron, therefore He2 plus is paramagnetic. Now on the same lines you please check whether H2 plus and H2 minus, do they exist? I have shown you the existence of H2 molecule. 1s2, right? S2 was there. It was diamagnetic. Now 1 electron is less here. 1 electron is less means bond order will be half. 1 minus 0 it will be. So it will be half. Half means it exists. Paramagnetic. How about this? It has 1 electron extra. So 2 plus 1, 3. So again it will be on the same lines. Bond order is positive. Therefore He2 minus also exists and it is paramagnetic. Okay. I want you to write energy level diagrams for these. Okay. Whenever you are drawing energy level diagram for molecules, you have to write a line here from lower energy level to higher energy level. The electrons are being filled. Can you see this pink line? This is the order in which the electrons are being filled. First is 1s, then 2s, and then 2 orbital is 2p orbital is filled. Now we shall look for lithium. Atomic number of lithium is 3. So its electronic configuration will be 1s2. 1s2. I'll write 2 electrons here and 2s1. In lithium molecules, how many lithium atoms are there? There are 2. So electronic configuration of one lithium is 1s2, 2s1. Another lithium is 1s2, 2s1. Now in molecular orbital, how they are filled according to Hund's rule. So one electron from here comes, another will come here. So 2 more are left. So 1 and 2. So 4 electrons are filled in 4 orbitals. Now how many electrons are here? How many are here? 2. So where they should go? to bonding molecular orbital. First one will come, another one will also come, and pairing takes place. Now we shall calculate bond order. So how many electrons are there in bonding molecular orbital? 2, yes, 1, 2, 3, 4. Antibonding 2, right? So once again I have written here, atomic number of lithium is 3. Therefore lithium molecule has 6 electrons. Bond order is equal to half of Nb minus Na. Nb means number of electrons in bonding molecular orbital and number of electrons in antibonding. So how many are there in bonding molecular orbital? 4. How many in antibonding? 2. So half into 2 is equal to 1. Therefore lithium molecule exists and they are held by one covalent bond. Since all are paired electrons, see here, everywhere it is paired, therefore it should be, yes, very good, diamagnetic. After lithium comes which element? After lithium you have, first one is what? Hydrogen, helium, He, okay, lithium, beryllium, and then Becknoff, BCNOF. So we are looking into beryllium, whose atomic number is 4. This is 1, 2, then 3, and this is 4. So atomic number 4 means what should be its electronic configuration of first beryllium? 1s2, 2s2. Very good. So I will make it 2. So for another beryllium it will be 1s2, 2s2. So I am going to go on filling bonding and antibonding molecular orbitals. How many are here? One will come here, another one will come. So altogether how many electrons are there? 4. How many molecular orbitals are there? 2. How many they can hold? 2 each. So 2 plus 2, 4 completely filled. 1s is completely filled. How about 2s? How many electrons are here? 2. How many are here? 2. So 2 will come here. The remaining 2 will go to anti-bonding molecular orbital. Now how many bonding electrons are there in the bonding molecular orbital? 4. Anti-bonding, how many are there? 4. 4 minus 4 is 0. 0 into half is 0. So does beryllium molecule exist? No. So it will be, as I said, beryllium molecule. Atomic number of beryllium is 4. Therefore beryllium should have 8 electrons. Bond order is half of Nb minus Na, that is half of 4 minus 4 is equal to 0. So beryllium molecule does not exist. It is monoatomic in nature. So which is the next element? After beryllium it is boron, atomic number 5. So what should be its electronic configuration? Yes, what will be its electronic configuration? 1s2, correct? 1s2, 2s2, 2p1. So I will show here 2px1. This is for one boron. So another boron, it is 1s2, 2s2, and then 2px1. So now you already know these 1s orbital and 2s orbitals are completely filled. So we will go to 2p orbitals. So 2px, one electron will come here. Another electron, where it should sit? Should it get paired or it should be unpaired? Initially they are filled alone and then pairing takes place. So I have filled it like this. So how many bonding molecular, how many electrons are there in BMO? How many are there? 2, right? 4, 5 and 6. Altogether there are 6 electrons in BMO. And ABMO, how many are there? Are there in any in P? No. How many are there in 2s? 2. 2p, 1s, 2. So in boron, I have shown it here, boron atomic number 5, it has 10 electrons. So bond order is half of number of electrons in bonding molecular orbital. 2 in 1s, 2 in 2s, 2 in 2px and 2py. So altogether there are 6 electrons. And how many in antibonding? 2 into 1. Number of electrons in antibonding is 4. So 6 minus 4 is 2. 2 into half is equal to 1. So boron molecule exists held by one bond and it is diamagnetic. So which is the next element having? Yes, after boron it is carbon. How many electrons? 6. So its electronic configuration will be 1s2, 2s2, 2p2. So I am writing 2p2 here. Understood how to do this energy level diagram? You have to just go on filling the electrons. So 1s and 2s are completely filled. 2px, 2py. How many electrons are here? 2. Here are how many are there? 2 altogether 4. So initially they will get filled singly and then pairing takes place. So third electron and the fourth electron. So we shall calculate bond order. Bond order for oxygen, atomic number of carbon. Atomic number of carbon is 6. Therefore carbon has 12 electrons. Bond order is equal to half of Nb minus Na. Number of electrons in bonding 2 in 1s, 2 in 2s, and then look here. How many in 2p? 4. So altogether there will be 8 electrons. So 8 minus antibonding 4. So half into 4 is equal to 2. Therefore bond order is 2. 2 bonds exist between 2 carbon atoms. Hence it is paramagnetic in nature. Okay. Understood. Then coming to nitrogen. So which is the next element? It is nitrogen. After carbon, nitrogen. Atomic number 7. So again, rewrite the configuration. It is already written 1s2, 2s2, 4 electrons. How many more you need? 4, 5, 6 and 7. Very good. For another nitrogen atom, 1s2, 2s2, 2p3. Altogether 7. 2, 4, 5, 6, 7. Now, how many electrons are there totally? 6. How many have been filled? 4. So 2 more. With where they should come? They should come to sigma pz orbital. So altogether there are 6. Now calculate the number of bonding electrons. How many are here? 6, 7, 8, 9, 10 bonding electrons. Antibonding 2, 3, 4. So here there aren't any antibonding electrons. So for nitrogen atomic number is 7. Therefore nitrogen molecule has 14 electrons. So bond order is equal to half of Nb minus Na, half of 10 minus 4. So half into 6, that is equal to 3. Therefore 3 bonds exist between 2 nitrogen atoms in nitrogen molecules. Since there are no unpaired electrons, it should be what? No, any unpaired electrons are here? No. So it should be diamagnetic. Very good. From oxygen atom onwards, there is a slight change in this particular diagram. From oxygen onwards, 2pz, that is 2pz will have lower energy compared to 2px and 2py. So that is written, only this is reverse. This will go up and this will come down. Rest everything remains the same. Okay, this I have shown here. So you only changes, you have to make change in the position of 2px and 2py. 2pz will come here, x and y will go up, which is shown here. Hope everybody is clear. Yes? Both I have shown. Right. Coming to oxygen. So what happens in oxygen? What is atomic number of oxygen? O8. So we will fill the orbitals 1s2, 2s2, 2p4, altogether 8. 1, 2, 3, 4, altogether 8. The same holds good for another oxygen atom, 1s2, 2s2 and 2p4. 1, 2, 3 and the fourth one. So altogether how many electrons are there? 4. So 2 molecular orbitals, easily you can fill them. Now coming to 2pz orbital. So altogether how many electrons? 4 plus 4, 8. So just go on filling. 1, 2, 3, 4, 5, 6. Then where should the other two go? 7. Should I get it paired? No. Initially unpairing and then pairing. So altogether 8. 4 plus 4, 8. So 2, 4, 6, 7, 8. It is complete. Now you have to find out what? Find out number of bonding electrons and anti-bonding electrons, and then calculate bond order. Try to calculate bond order now. Atomic number of oxygen is 8. Therefore oxygen molecule should have 16 number of electrons. So bond order is equal to half of 10 minus 6, that comes out to be half into 4, that is equal to 2. So oxygen molecule has 2 bonds between it, which is shown here. O double bond O. Hence, since it has unpaired electron, okay, look here, it has how many unpaired electron? 2 unpaired. Though because it has unpaired electron, it is very good paramagnetic in nature. So which is the next element? Next element is after oxygen, it is fluorine, atomic number 9, and the last one is neon, atomic number 10. So for both fluorine and neon together we will fill energy level diagram and then check bond order. Okay, so fluorine 9, so 1s2, 2s2, 2p4, and this is our 5th electron. And how about this? Our 5th electron. So what should happen? Pairing should take place here. Altogether 5, 5, 10. So 2, 4, 6, 7, 8, 9, 10. So are there any unpaired electrons? No unpaired electrons. No unpaired electrons means what? No unpaired electron means it is very good diamagnetic. Now we need to check whether any bond exists between the two fluorine atoms. Can you tell me how many electrons in bonding? 1s, 2s, then 4 plus 6, 10. Anti-bonding 2, 4, 5, 6, 7, 8. 10 minus 8 is 2. 2 divided by 2 is equal to 1. Therefore, bond order of fluorine is 1. Okay. And how about neon? How many electrons are in 2p? 6. So, what is atomic number of neon? 10. 1s2, 2s2, 2p6. 6 plus 2 plus 2, that comes out to be 10. So, I will add one more electron here, and both these electrons will go to this orbital. So, all your bonding and anti-bonding orbitals are completely filled. There are 10 electrons in bonding molecular orbital and 10 electrons in anti-bonding molecular orbital. So 10 minus 10 is equal to 0. So bond order is equal to 0. Therefore, neon molecule does not exist. It is monovalent. Here I have shown again calculation of bond order for fluorine. 18 electrons, bond order is equal to half of Nb minus Na, half of bonding molecular orbital has 10 electrons, anti-bonding has 8, so bond order comes to be 1. So, fluorine molecule has one bond which is shown like this, no unpaired electron, therefore diamagnetic. Atomic number of neon is 10, it has 20 electrons, so bond order is half of 10 minus 10 which comes out to be 0. Therefore, no bonds exist, neon molecule does not exist, and therefore it is monovalent. I think with this we have completed chemical bonding chapter. To understand this, you need to repeatedly write energy level diagrams starting from atomic number 1 to atomic number 10. It will change after which element? After nitrogen. There is slight change in the p orbitals. Hope you have followed everything. Thank you very much.